Experiment performed using a parallel above, the small disk mass M, and for this kind of question, it's a experimental problem that we need to deal with the experiment values, data, and graph. Experiment performed using a parallel above, a small disk mass small m attached a frictionless table attached to one end of the string. The string passes through a hole in the table and an attached narrow vertical plastic tip. An object mass M2 is hung at the end of the string. A student holding the tip makes the disc rotate in a circular constant radius, while another student measures the period P. We write the equation P that relate P and M2. The procedure is repeated and the period is determined for 4 different values of M2, where M1 is 0.012 kilograms and the radius is 0.8 meters. The data, which are presented below, can be used to compute an experimental value for G. What quantity should be graphed to yield a straight line with a slope that could be used to determine G? Okay. Yeah, copy this question on the board. We need to do 2 screenshots, not a single one. Here the monitor is horizontal. And okay, the graph B and C and D. Any other question below? Okay. We are given this equation P equal 2 pi M1R and divide M2G. We need to derive this thing. The period relate to M1 and M2. Okay, question A. The period P is the term for 1 revolution. It means 2 pi r the circumference divided by the speed. Okay, but how do we find the speed? Narrow vertical derived equation M1 r M2G. Okay, the tension acting on the object 2, the disk M2, must be equal to the weight M2G. Tension up. And this tension is equal to the tension acting on the M1 also. And that tension is equal to the centrifugal force Fc equal mv square m1v square over the radius r. Okay. Okay, so we have the equation m2g equals m1v square over r. We want to find v from this one, the period here. So according to this equation here, v is m2g multiplied with r divided by m1 and then take the square root. Okay.
Yes.
And finally plug in here. So the period is 2 pi multiplied with r. This is little r, not big R. Okay. Little r divided by this thing, the square root of m2 gr over m1. And now we simplify this thing. R outside at the top, divide r in the square root, resulting in r in the square root. And we can put the 2 pi in front of that. So m1 will be at the top along with the small r now in the square root, okay, divided by m2g, which is proven. Okay.
Yes.
So the point is the understanding of the force equilibrium here, the tension equal to the centrifugal force and equal to the weight of the second object. Question A is done. Now question B. What quantity should be graphed to yield a straight line with a slope that can be used to determine G? We need to determine G from this equation. Because G is inside the square root, so we need to square both sides so that the period square equal to 4 pi square times m1 r over m2g. So the variable is r for m1. Wait, m1, m2 is change. M2 is change. M1 is constant. Radius constant. Everything is constant, and the thing that is changing the variable is m2. Okay, changing m2.
Yes.
And we need to find g. Anyway, we should reverse m2. Yeah, reverse this equation first, meaning 1 over p squared equal g m2. M2 I can write that outside because that is a variable and this is the gradient in front of it. G m2 over 4 pi squared m1. Okay, so this is the variable x. This whole thing is y, and the thing here is the coefficient, the gradient of the graph, linear graph, where the vertical axis is y, which is 1 over p squared, and horizontal axis is x. Okay.
Yes.
So yeah, plotting the graph like that, and your answer is the vertical axis is the reverse of p squared. One over p squared. The horizontal axis is m2. Okay, and so that the gradient, which result in the gradient. So that the gradient is g over 4 pi squared and m1. From this, measuring the gradient on the graph after plotting the graph with the given data value, okay, determine that gradient, and then you can do the calculation to find the value of g. Okay.
Yes.
The quantity should be graphed to use the straight line, the globe, and the slope that used to determine g on the grid below. Plot the quantity, determine that. Label exists, the draw best straight line. Okay. Let's get through this part by looking at the answer, and you will do it again by yourself. Okay. Plotting the graph on a real on a tablet or real paper with these values. Okay, and do solving this problem again. Okay.
Yes.
The answer. There's no answer as such. It's weird. Okay. So yeah, it takes some time, but anyway, we need to do it. M2 on the horizontal axis, the greatest value is 0.08. I can put it here. It is 0.08 for M2, 0.06, 0.04.
Oh, I found the answer of this one.
Which page? The number of the page?
97.
97. Okay. Okay. P square. Okay, the answer may be grabbed to give straight line r p square and 1 over m2. Okay, they do it oppositely with my method, Yeah, so you can do this way again by yourself with this method. But for now, I still like to test if this method is like a little bit faster. I usually prefer using M2 on the horizontal axis instead of the inverse of that. The reverse of that. Okay. Plotting the graph now. M2 0.02 here and 0 here on one side. The p square, we need to do the calculation of p square and 1 over p square, 1 over p square. Do the calculation. I'm opening the calculator. Okay. 0.02 for the no. Only 1 divided by p square. For the first value, p is 1.4. 1.4 square. Where's the square button? Okay. We need to reverse the calculator here. This value 1 over p square is 0.51. The next one, 1 over 0.05 square. is 0.907. 907. We can round to 91, huh? Taking 2 decimal places. Next one, 1 over 0.8 squared. 1.563. 563. Okay, and lastly, 1 over 0.75 squared. 1.78. 1.778. Okay, now plotting these values on the exit. The maximum is like 2. I can make 2 here, huh? So it is about 1.8, which is here. For this value M2, this is 1 point. This is 1 point, okay? The second point, let me change to the red color. 1 point here. 0.06, the inverse of 1 over p squared is 1.5, which is 2. Wait, 2 should be here. Sorry. For rectangle, like 0.5 here, 1 here, 1.5 here, and 2 here, huh?
Yes.
So that 1.8 is here. 1.56, approximately 1.6, huh? 1.6 is about here, a little bit lower than that. Next one, 0.9. 0.9 in the middle here, huh? And lastly, 0.5, a little bit greater, but doesn't matter right here. Okay, so it's not a beautiful straight line, huh? It's a okay, and we have no information about the error bars. We have to draw a straight line like this. 2 points on the way. Should be 2 points above the line and 2 points below that, huh? So difficult. Should be like this. Okay. Anyway, if I try like this, calculating the gradient and then the g, hopefully that it will give the same answer with the answer here. But do it yourself again, okay? This afternoon or tomorrow.
Yes.
Okay. For this straight line, wait, check it again. For this 0.8, 0.6, 0.6, 1 over.
I think you checked 1.6
yeah,
wrong.
I'm checking that. 0.8 squared. 1.6. Can you say again?
I think you check wrong in the graph.
M2 in a horizontal exit. Vertical exit 1 over p squared. 1.05. The history of the calculation. Anyway, do it again. 1 over 0.05 squared. Is correct. 1 over 1.4 squared. 0.8 squared. Okay. This is wrong. This value right here wrong. Okay. So I will do this point again. 1.5 here, huh?
Yes.
Yeah. And it is almost 1.56, a little bit greater here in the middle. Okay. So now we have a pretty beautiful line. Okay. The radian is calculated by rise over run. I will take this value to be okay. No, take this instead, huh? Very close to 2, huh? It could be like 1.9, 1.95, okay? For this position, okay?
Yes.
This position 1.59, and subtract the lower value here is about 0.45, and then divide the run, which is 0.08 minus 0.02, huh?
Yes.
Okay. 1.95 minus 0.45, and then divide 0.06. The radian is 25. 25. That radian is equal to Yeah, G divided by 4 pi square and M1. 4 pi square and M1. So we are calculating G, huh? G is that value 25 multiplied with 4 pi square and M1 to be how many kilogram? 0.012 kilogram. Very small mass, huh? 0.012 grams. So G is 25 multiplied with 4 pi squared times 0.012, 11.84. Funny value. 11.84 meter per second square. Comparing it to the answer, 9.97. Okay, do it yourself later. Okay.
Yes.
So this is not a good best fit line. We need to do it again. This method, my method, or the method in the mark scheme, you understand that method, right?
Yes.
Instead of the vertical axis is the inverse of p square, we can take the vertical axis p square and horizontal axis 1 over m square. Okay, so that the
Yes.
radian is m 4 pi square m1. Wait, what is r here? Wait, I forgot the r, huh? I forgot the r here. Yeah. 4 pi square. Okay, inverse that. So that is m1 r at bottom. Sorry, r at bottom here.
Yes.
So here I put the r in here. And then multiply with that r, huh, which is how long is that r, the radius? 0.8. Oh, it's now approximately beautiful, huh? Instead of 11, okay?
Yes.
This number 11 times that radius r. Now it's beautiful, 9.47, huh? It could be a little bit better if you do it on a real paper, 9.47. And you can get a result which is approximately equal to this one. Okay?
Yes.
Okay. Anyway, do it again by both methods. Plotting the two type of graph, do the calculation of the gradient and the value G. Okay?